In this section, we'll be handling maxima and minima. Every curve has a turning point. If it was going up and it makes a turn and starts coming down, this point is called a maximum point. If it was going down and it makes a turn and starts going up, this point is called a minimum point. If it was going up, it wants to come down, it continues going up, this point is called a point of inflection or a saddle point. So how do we determine this point when we have a curve? What we'll do again is an application of differentiation, so we differentiate again. So the question says find the stationary point. A stationary point is also called a turning point, where it's making a turn. Find the stationary point of the curve y is equal to x squared minus 5x plus 2. So we'll differentiate, and when dy dx is equal to 0, we'll have a stationary point. Okay, so we'll determine if that stationary point is maximum or minimum, depending on our second derivative. If we differentiate twice and our result is positive, then we have a minimum point. This minimum will have a positive d squared y over dx squared. If we differentiate twice and our result is negative, we have a maximum, negative d squared y over dx squared. If we differentiate twice and our result is just 0, we have a point of inflection. So in this question, we'll be taking this example, y is equal to x squared minus 5x plus 2. So let's go. Firstly, we'll differentiate the y over dx. So differentiate x squared, we'll get 2x. Differentiate minus 5x, we'll get minus 5. Okay, so we said set the y over dx equal to 0 and solve. So we said 2x minus 5 equal to 0. We'll have that 2x is 5, and we'll have that x is 5 divided by 2. So x is 5 over 2. And since we have only one value of x, we don't need to do the second derivative. We simply leave it that way. But when we have two values of x, we must confirm which of them we are using by doing a second derivative and substituting the values. The one that gives us negative is the x that we use when we're looking for maximum. The one that gives us positive is the x that we use when we're looking for minimum. Okay, so now we have x is equal to 5 over 2. And the question says find the stationary point. So this is the value of x. So we'll go on to find the value of y. So for us to find y, we'll substitute. Y is equal to, instead of saying x squared minus 5x plus 2, we'll replace every x with 5 over 2. So 5 over 2 all squared minus 5 bracket 5 over 2 plus 2. Then we'll simplify it. 5 over 2 all squared will give us 25 over 4. Then we'll have 25 over 2, that is when 5 multiplies 5, and then we'll have plus 2 over 1. So we can simply use LCM. The LCM is 4. And then 4 into 4 is 1, 1 times 25 is 25, minus 2 into 4 is 2, 2 times 25 is 50, plus 1 into 4 is 4, 4 times 2 is 8. So what we have is that y is equal to 25 minus 50 plus 8. So 25 minus 50 is minus 25. And minus 25 plus 8 will give us minus 25 plus 8 will give us minus 17. Am I right? Let me do it the other way. 25 plus 8 will give me 33. 33 minus 50. Yeah, I was right. Minus 17. So what I have is minus 17 divided by 4. And so our stationary point is x comma y. So x comma y is x is 5 over 2 and y is minus 17 over 4. So I'll go through it again. Okay. So what we do when we're looking for a stationary point is that we differentiate, set our dy dx equal to 0, get the value of x, that's what we've done here, and then if we're looking for a stationary point or a turning point, that's a maximum point or a minimum point, we'll substitute that value of x into our y so that we get the value of y, and then we say x comma y is the point. So the y dx is 2x minus 5. That means x is 5 over 2. Substitute 5 over 2 for x everywhere. That means we'll have 25 over 4 minus 25 over 2 plus 2 over 1. And then we simplify, and this is what we get, minus 17 over 4. So x plus y, rather x comma y, is 5 over 2 comma minus 17 over 4. So that's the point. So this point, you can ask yourself, is this point now a maximum or a minimum or a point of inflection? If we want to find out, we'll differentiate again. If we differentiate 2x minus 5, we'll get 2. And 2 is a positive number. That's to say that this point is a minimum point. So that's where we stop. Bye-bye.